On behalf of 24HourAnswers.com, I welcome you to today's lesson. In this video, we're going to look at 4 special limits, and the reason that they're special is because, well, notice all these, the x values approaching 0, and here we can't plug 0 into our denominator because we cannot divide by 0. Same thing for this one, same thing for this one, and then this last one down here, we still have a 0 in our denominator of our rational exponent up here. So I want to show you these on a graph, and we're going to look at Desmos for this, but then I'm going to show you a few things on the TI-84 as well. So the first graph that we have here is y equals sine of x over x, and we're letting x approach 0 here. So notice as I let x get real close to 0, it looks like the y value is getting close to 1. As you can see right there, that y value is 0.993, and I can get even closer, but eventually when I hit 0, it's going to be undefined, as you can see right there. But our y value is getting close to 1, both on the right hand side and the left hand side. That's that first example there. For our second example, tangent of x over x, as x gets close to 0, we are also approaching a y value of 1. And notice right there, as we get close to 0, watch the y value is getting closer and closer to 1 as this x value gets closer and closer to 0. And notice once I hit 0, again, we're going to have that undefined piece right there. But as we approach 0 from the right and as we approach 0 from the left, our y value is getting close to 1, hence that special limit right there. This third example, the limit as x approaches 0 of 1 minus cosine of x over x, again we cannot directly substitute 0 in here because of the same reasons for the first two, but notice as we get close to an x value of 0, y is also getting close to 0. Notice that right there. X is pretty close to 0 and y is pretty close to 0 as well, but once we hit 0, notice that we have undefined. We have a hole in the graph. And the same thing happens coming in from the right hand side. As x gets close to 0, the y value also gets close to 0. But again, we have that hole right there. And now for our last one here. As x gets close to 0 here, the problem lies up in our rational exponent because we have 1 divided by 0 if we try direct substitution. Well, what I want you to notice is that I have typed in E right here. Also on your TI-84, which is the calculator that you're going to be using quite often, if you press second and divide, that's going to give you the E, and press enter, notice we get 2.71 blah 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 blah. Well, this is what we're going to be approaching as x gets close to 0 in this particular function that we have here. Now we could look at that on the TI-84, and I'm going to come back at the end and show you a little tip there, but notice as I get close to 0, as x gets close to 0, look at this y value. Look at this y value right here. So x is pretty close to 0, y is around 2.5. I'm going to get a little bit closer and a little bit closer, and notice we are getting close to that 2.71. I can get even closer, right about there it's undefined, but notice we are still getting really close to 2.718. To show you that further, I'm going to plot a point at 0, E, and notice that black dot right there. That black dot is right there on the orange curve, but really it's not because remember, we do have a hole right there. But what I want to show you here is that yes, we are getting close to that value of E, even though this dot here is not really on the curve because of the hole in the graph. Now for some TI-84 tips. Let's just take one of these random functions here, the sine of x over x. I'm going to type that into the calculator and y equals. Going to make sure I'm in radian mode. And back in y equals, I'm going to press zoom and let's just zoom trig, zoom 7. So we had that same curve that we had in Desmos. So I want you to feel comfortable with using your TI-84 as well because you will not always have Desmos beside you. So we can press trace on the TI-84 and we can start tracing along this curve. And this little dot that we see here, I'm going to let this x value get close to 0. And notice that y is going to be getting close to 1, that limit that we have right here. So getting closer, closer, closer. But notice when we hit 0, y is not showing. That's the same thing as us seeing a hole in Desmos. But if I come over here to the left-hand side, as we get closer to 0, coming in from the left, we're getting closer to that y value of 1. Another thing I'd like to show you is the following. Let's go to Second and Window for our table setup. Let's tell our table to start at 0. Let's do our delta table for 0.01 and make sure everything is set to auto. Now what this is going to do, this is going to start our table. If we press second and graph, we're on our table, and what I want you to notice is that as we get close to this 0 value, whether we're coming in from the left hand side, that's negative values, or the right hand side, look at these decimals here. They're getting really close to 1. As a matter of fact, on the TI-84, we get so close to 1 here that it shows 1, but I do hope that you notice it's not technically equal to 1 yet. It's really close to 1, but then when we come and hit 0, notice we do have that error. We have that hole in the graph. Now, very similar techniques could be applied by typing in any of these functions. You could use the trace feature on the graph, or you could do the table setup where I adjusted my delta table to fine tune those x values. That way I can find a limit using a table on my calculator. And there you have it. Quite a few things covered here. 4 special limits. We looked at them on Desmos, and then we also looked at the TI-84 where we looked at the graph itself, and then we also looked at the table to determine some of these limits. And that's it for this video. I hope it helped. Be sure to check out our YouTube channel for more videos. Links to our social media are in the description below.